In this lesson, we're going to go over unit analysis. Specifically, we'll learn about the use of units, identify keywords and operations with units, and use unit analysis to solve problems. First, what are units? Units are really important. Oftentimes, when we look at cost or price tag, it's per a certain unit, like price per gallon of gas, or cost per ounce, or price per soda, or something along those lines. Okay, so we'll use units to solve problems, and sometimes units can be confusing, so it's really important that we understand them and we learn how to work with them. So in this section, we'll talk about certain keywords with units, we'll talk about converting units, and then we'll also continue to use dimensional analysis, or a way to organize our work to make sure we're ending up in the correct spot when working with unit conversions. We have different types of units. We have units that deal with volume, such as liters or cups. We have units that deal with length, such as meters or feet. Okay, and also, if you track your food in any kind of system like MyFitnessPal, grams are sometimes better than ounces. They can be more accurate. So units can be practical in that sense as well. So vocabulary. So units are a description of what a quantity measures or counts. So in the example of 45 pounds, 45 is the quantity and the unit is the number of pounds. So if you ask me, or if I say, hey, I need to borrow money, and you say how much, and I say 5, is that $5, $500, 5 cents? What are we talking about here? So units you can think of are a way to label something or to help us understand what is being communicated when we're talking about certain quantities. Unit analysis is the process of working with units to help us solve problems. Keywords. So the word per usually denotes division. A common example of that is a car, or speed limit signs are in miles per hour, which means that that's division, or we can write miles on top, per as our fraction bar, and then hours. Of or a hyphen denotes multiplication, kilowatt hours or kilowatt hours. If you're paying your own power bill, you may see this on the bill. Square, we're raising something to the second power, so feet times feet would be feet squared or square feet. Cube or cubic is when we're raising something to the third power, so feet times feet times feet is cubic feet, or whatever the unit is. You could have cubic meters or something like that. Conversion factors help us change a desired set of, or a given set of units into a desired set of units. It's a statement of equality to convert between units that were given. So for instance, 12 inches is equal to 1 foot. So we can write that in a couple different ways. 12 inches per 1 foot, or 1 foot per 12 inches are two conversion factors for this relationship, and which one we use depends on what we're trying to convert. So example 1, using keywords. So you are buying 40 acres of farmland at $14,500 per acre. What is the total cost? Okay. So if we write a table, and I like to kind of describe or show what's happening before we jump into the math. So 1 acre is 14,500. 2 acres is 14,500 times 2. 3 acres is 14,500 times 3. And you see where this is going. We take our cost times the number of acres, which will give us our total cost. So in this problem, to get the final answer, we would have 14,500 per acre, and we're multiplying it by 40 acres. Okay, so notice here I've set this up in a way that allows the units to cancel, and we're just going to be left with cost, which is going to become very important in some of the other problems we do. So I'm going to multiply this out. 14,500 times 40 gives us 580,000. Next example, using unit analysis to reason. So if I can run a mile in 11 minutes, which is equivalent to running 15 feet per second, does that make sense, or is it true? So let's break this down in a couple of different ways. The first part, I can run a mile in 15 minutes is another way of, or in 11 minutes is another way of saying 1 mile per every 11 minutes. Okay? We want to know if that's equivalent to 15 feet per second. So our goal with what we're trying to reach is our answer needs to end up in feet. per second. So when we set up our conversion factors, this is what we need to end up with. Okay, so we'll continue to use dimensional analysis to set this up. You can choose to work with miles or minutes first. It doesn't matter. I'm going to work with miles, and my goal is to get to feet. So if miles is in the numerator or on top, miles needs to be in the denominator so that those units cancel out. My goal is to get to feet, and I know that there's a conversion. There's 5,280 feet per 1 mile. These will be given to you in the homework. Okay, so then I fill this in. Feet goes with feet, miles goes with miles. 5,280 per 1 mile. Okay, and I check, my miles will cancel out and I'm left with feet, which is my goal. So that unit of length is done. I've converted that, or almost, but I've set it up to convert it. Next, let's talk about minutes. Our goal is to get to seconds, and we may remember that 60 seconds is equal to 1 minute, okay? So when we're setting up our units, do we put minutes in the numerator or the denominator? Well, that depends on what we're trying to cancel here. Since minutes is in the denominator, it's going to go in the numerator so that they cancel, and then we'll put seconds in the denominator, and that's also our goal. We need to end at feet per second. Okay? We know that there's 60 seconds per minute, so we have 60 per 1 minute, and that would mean that our minutes cancel out. So if we take a look at this, our miles cancel with miles, our minutes cancel with minutes, and we're left with feet per second. Now to solve this problem, we multiply what's left on top. 1 times 5,280 times 1, and we know that this is in feet, over 11 times 1 times 60, and this is in seconds. And so we would use the calculator or do our math for this problem, and we would get 5,280 feet divided by 660 seconds, which reduces to 8 feet per second. Okay? So does it make sense that someone who can run 1 mile in 11 minutes is equivalent to 15 feet per second? And that answer would be no. We just showed it's actually equivalent to 8 feet per second. Example 3, using unit analysis to compare. So Portia and April take a 3,000-mile cross-country trip in their own cars. Why they're driving separate? Not sure. Portia's car has a 12-gallon tank and averages 40 miles per gallon, and April's car has a 20-gallon tank and averages 30 miles per gallon. How much will they each spend in gas for the entire trip? So let's say gas, I think it's about $2.87 right now. So we'll use that. So $2.87 per gallon. It's important that you know that this is per gallon. Okay. So let's talk about Portia for a minute. We'll start with Portia. And we'll draw a table. So on 1 gallon of gas, Portia can drive 40 miles, which means that she would spend 1 gallon times $2.87. On 2 gallons of gas, Portia could go another 40 miles, which would be 80, which means that she spends 2 times 287, ... So we see where we're going with this. We need to determine how many miles per gallon she can go for a 3,000-mile trip. Okay, so notice here that 80 divided by 40 is 2. 40 divided by 40 is 1. So when we go to determine how many gallons of gas Portia is going to need, we can take 3,000 divided by 40, and that would tell us how many gallons of gas Portia will need. So we take 3,000 divided by 40 to get 75. Okay, so 75 gallons of gas will get Portia 3,000 miles. And then to determine cost, we take 75 gallons times the cost per gallon. Notice gallons would cancel out, and that would give us the final amount. So if you plug this into your calculator, we would get $215.25. So setting up the table or reasoning through it at smaller amounts rather than jumping to 40 miles per gallon, start at what can happen at 1 gallon, 2 gallons, 3 gallons, etc. to help make some sense of the problem before jumping into the math. Let's go on to April. April's car averages 30 miles per gallon. Okay, so on 1 gallon of gas, April can go 30 miles, and that would cost $2.87. On 2 gallons of gas, April can go another 30 miles, which would be 60, which would be 2 times $2.87 in cost per gallon. So we keep going. We want to get to 3,000 miles. So we would take 3,000 and divide by 30, which would give us 100 gallons. So April would need to use 100 gallons of gas to go 3,000 miles. So to determine cost, we take 100 gallons times $2.87 per gallon to determine the total cost, which would give us $287. So thank you for watching. If you have any additional questions about units or converting units, please feel free to reach out to me.